Hi, this is Miss Morgan, and in this video we're going to talk about enzymes. So on page 45 in your interactive notebook, go ahead and title that Enzymes. Don't forget to update your table of contents, and then draw this foursquare on page 45. So in our first box, let's begin by talking about structure of an enzyme. Now, if we go back to our notes on page 41 in our interactive notebook, we can find out what type of biomolecule enzymes are. So right now, go back and look and see if you can figure out which biomolecule enzymes fit into. If you found out that enzymes are proteins, you are absolutely right. Enzymes are made of protein, and so all enzymes are proteins, but not all proteins are enzymes. Remember, there's lots of kinds of proteins. Enzymes are just one type. So here's an example of an enzyme here. And remember that enzymes are, as a whole, are going to be polypeptides. They're a polymer. Each section of the enzyme, each piece, is a monomer. So the protein is the polypeptide polymer. And just as a reminder, remember that the monomers, or the pieces of a protein, are called amino acids. Oops, can't spell acids. There we go. So, since the monomers of a protein are amino acids, the monomers of an enzyme are also amino acids. Now, enzymes come with lots of different names. So here's some examples of a few enzymes. We've got lactase. And we could add amylase. Amylase is what is in your mouth, in your saliva. We've also got, what else could we put? We could put down trypsin. And we could put down sucrase. Right? So all four of these things are enzymes. Now take a minute and look at these four different examples of enzymes. What do you notice that all four of these enzymes have in common, or at least three of them have in common? If you said that they all end in ase, you are exactly right. Now, trypsin doesn't. It's an exception to the rule. There are some enzymes that do not end in ase, but most enzymes end in ase. So we can say that enzymes are aces. And that's a good way to remember how they end. So if you're ever reading a question and you see ASE, that means that that is an enzyme. So what they break down is oftentimes going to be a similar word. So lactase breaks down lactose. Amylase breaks down amylose. Sucrase breaks down sucrose. So trypsin's a little different. Trypsin is an enzyme that can break down a few different things. So we're just going to say that trypsin breaks down proteins. Trypsin's found in your stomach, and so it's what we call a proteinase. You don't need to know that. It's just a little bit extra information. But you're going to find this in your stomach to help with digestion. Because enzymes break things down, they do a lot of digestion. All right, so that's all about structure of enzyme. So next up, let's look at functions of enzymes. All right, so in chemistry, we have chemical reactions that occur. So here is a chemical reaction where we have a molecule of lactose. We add in some lactase enzyme, as well as some energy. And we end up breaking that apart during the reaction into two molecules, one of glucose and one of galactose. Okay. And we put a little plus sign here to show that those two things are both of our products. So here we have a reactant. I'm going to label that in a different color for you. And here we have products. Now, in order to start a reaction, let me grab a different color here. You'll notice that we added in some energy. All chemical reactions need some energy to get them started. The energy that they need to get started is called activation energy. So this is energy needed to start a chemical reaction. So every chemical reaction has a specific amount of activation energy that it needs to get started. So let's do a little demo here to show you how this works, and then to show you what an enzyme does. So I'm going to get rid of my enzyme, and I'm going to start with this beaker here. And this beaker is going to represent the amount of activation energy that I need to start this reaction. I also have some marbles, and each marble is going to represent one photon, or basically one packet or one piece of energy, if you want to think about it that way. So this is one piece of energy. This is the amount of energy I need to start a reaction. So let's do a little timed experiment here and see how long it takes for us to build up enough energy, in other words, to fill this beaker so that we can start a reaction. All right, let me get my stopwatch. Okay, here we go. So I'm going to add energy one piece at a time. Alright, so we're already at 30 seconds, and I haven't even added enough energy for us to get half of the activation energy. About a third full. So let's keep going. Alright, I still can't start my reaction yet. Still can't start my reaction. We're at a minute and I'm just now about halfway full. So still adding energy. Still adding energy. Can't start the reaction yet. Alright, let's get some more energy here. Refill. Oops. Still not there yet. Whoops, I got marbles rolling away on me here. That's a really big piece of energy there. Alright. Adding in energy still. We're getting closer. We're almost full now. Get an energy refill here. Still going. Still going. Whoops, I got marbles going everywhere. looks like my beaker is finally full up to the top. So I'm going to stop my timer, and it took 2 minutes and 9 seconds to get enough activation energy so that we could start a reaction. All right, so let's start, and let's draw a picture here. And let's show our green beakers. So this here is activation energy needed. And we're going to fill that up with energy molecules. Ooh, even drawing these takes a while, right? Okay. And this was done without an enzyme. So we're going to make a note that this is without the enzyme. Okay. So let's do part 2 of this now. So in comes our enzyme. Choo-choo, choo-choo. Sorry, couldn't help myself. And what an enzyme does is it takes the original amount of activation energy and it lowers it. So instead of needing this whole beaker full of activation energy, now we only need this beaker full. All right. So this is the amount of activation energy now that we need to start a reaction, and that's because my enzyme is present. So let's do this demo again, and let's see how long it takes now to start the reaction now that the enzyme has lessened or reduced the amount of energy needed. Let's reset the clock. All right, here we go. Let's start adding energy. Energy refill here. All right, we're actually overflowing with energy, so let's stop the clock. So you can see I have now filled up and gotten to the amount of activation energy I need so I can start the reaction. And it only took 21 seconds this time to be able to start the reaction, as opposed to the 2 minutes and 9 seconds it took to start the reaction without the enzyme. So let's add to our picture here. So with the enzyme, we have a smaller beaker, and it requires less activation energy. And that's because less energy was required to fill up and reach that starting energy amount. So take a moment and think about, when I added the enzyme in, what did the enzyme do to the amount of activation energy? Did the enzyme add energy? Did the enzyme take away energy? Or did it change the amount of energy needed? If you said that the enzyme changes the amount of energy needed, you would be correct. The enzyme does not add any energy. I did that with my hands, not with the enzyme. The enzyme didn't take away any energy. In fact, no energy was taken away. Instead, all the enzyme did was lessen the amount needed. So let's write ourselves a definition of what an enzyme does. And since I'm out of room, sorry about that. Since I'm out of room, I'm just going to add a little Post-it note in here to write my definition on. All right, so the function of an enzyme is to speed up a chemical reaction, and it does this by lowering the amount of activation energy needed to start the reaction. right, so I'm going to underline that word activation energy because that's one of our vocab words that we need to know. And remember, we defined it back here behind the Post-it note. Okay. One thing I want you to note, and I know we just said this, but write it down. Enzymes do not add energy. They lower the amount of energy needed. Okay. So they take away the amount of energy needed. They do not add energy. I added energy with my hands. Our enzyme did not put the energy into the container. All right, so we're going to stop there with our enzyme notes for today, and we'll pick up with the rest of this and model how an enzyme works in part 2. Thanks for watching.